Good day, everyone. Welcome to the Division, Remediation, and Enrichment of Aptitude in Mathematics through E-Learning, or eDream. Quarter 1, Week 8 of General Mathematics is all about solving logarithmic equations. After this video lesson, we must be able to solve logarithmic equations. Let's begin. Steps in solving logarithmic equations. Number 1. Isolate the logarithmic term on one side of the given equation. Number 2. Write the equation in exponential form. Number 3. Solve for the variable. And number 4. Check to make sure that you do not have an extraneous solution. Let's have our first example. So let's solve for the logarithm of quantity 8x to the base 4 equals logarithm of 24 to the base 4. So as you can see, we have the same bases. So all we need to do is to copy 8x and 24. So 8x is equal to 24. Dividing both sides by 8, x is equal to 3. Now let's check if 3 is the solution. So copy the given. Then substitute 3 on x. So instead of writing x, replace it by 3. The logarithm of 8 times 3 to the base 4, is that really equal to the logarithm of 24 to the base 4? So multiplying 8 and 3, as you can see, the left side of the given equation and the right side of the given equation are equal. Okay, therefore, we can say that the solution is 3. Next example, let's solve for the logarithm of quantity x plus 2 to the base 3 is equal to 2. So here, the best way to answer this is to rewrite it in exponential form. You have your base 3 and 2 here will serve as our exponent. So x plus 2 is equal to 3 square, and we all know that 3 square is equal to 9. Using addition property of equality, x is equal to 7. Now let's check if the solution is 7. So write down the given. Then substitute the value of x, which is 7. 7 plus 2 will give us 9. Now we write this in exponential form. 9 is equal to 3 square. And we all know that 3 square is equal to 9. Therefore, we can say that 7 here is a solution. For our third example, let's solve for the logarithm of 25 to base x equals 2. So then again, the best way to answer this is to rewrite the logarithmic equation in exponential form. Remember, you have your base x and exponent 2. So, x squared is equal to 25. Now, using addition property of equality, x squared minus 25 is equal to 0. Now, factor x squared minus 25, we will come up with the quantity x plus 5 times the quantity x minus 5, which is equal to 0. Now, using zero factor property, x plus 5 is equal to 0 and x minus 5 is equal to 0. We now have x is equal to 5 and x is equal to 5. Now we will check if the two of these are the solutions, or it can be either negative 5 or positive 5 is the solution. Let's check. So let's start with negative 5. Again, we have logarithm of 25 to the base x is equal to 25. Substituting negative 5 on x, we now have the logarithm of 25 to the base negative 5 is equal to 2. Okay, look at the base. The base is negative. And we all know that in logarithmic function or logarithmic equation, we must not have a negative base. Therefore, we can say that negative 5 here is not a solution. Let's try positive 5. So again, this is the given, the logarithmic The logarithm of 25 to the base x is equal to 2. Substituting positive 5 on x, we will have the logarithm of 25 to the base 5 is equal to 2. Using exponential form, or rewriting this in exponential form, 5 here is the base, 2 here will serve as our exponent. Therefore, 25 is equal to 5 square, and we all know that 5 square is equal to 25. So both sides of the given equation are equal. Therefore, we can say that 5 is the solution. Okay, for our next example and our final example, let's have the logarithm of quantity x plus 1 to the base 2 plus the logarithm of quantity x minus 1 to the base 2 equals 3. So as you can see, you have your plus sign and we have the same basis. So we may use the laws of exponent, which is the product property. So in the product property, all we need to do is to get rid of the plus sign and to multiply the two factors. So that will give us the logarithm of quantity x plus 1 times the quantity x minus 1 to the base 2 is equal to 3. Now we're writing this in exponential form. We all know that 2 here is the base and 3 here will serve as our exponent. So 2 raised to 3 is equal to the quantity x plus 1 times the quantity x minus 1, or vice versa. So multiplying this using FOIL method or using long multiplication, we may have x squared minus 1 is equal to 2 raised to 3. And we all know that 2 raised to 3 is equal to 8. Now manipulating the given equation using addition property of equality, we now have x squared minus 9 is equal to 0. X squared is a perfect square, 9 is a perfect square, the middle sign is negative, therefore we can factor this as x plus 3, quantity x minus 3 is equal to 0. Now using zero factor property, x plus 3 is equal to 0, x minus 3 is equal to 0, therefore the value of x are negative 3 and positive 3. Now let us check if the two of these are the solutions or one of these is the solution. So let's start with negative 3. So copy the given equation. Next is to substitute negative 3 on x. So we have the logarithm of quantity negative 3 plus 1 to the base 2 plus the logarithm of negative 3 minus 1 to the base 2 equals 3. And there we have here logarithm of negative 2 to the base 2 plus the logarithm of negative 4 to the base 2. So then again, you have here plus sign. So using laws of logarithms, we will multiply negative 2 and negative 4. And then we will change this in exponential form. 2 is the base and 3 is our exponent. Therefore, we will come up with negative 2 times negative 4 equals 2 cubed or 2 raised to 3. And we all know that negative 2 times negative 4 will give us positive 8, which is equal to positive 8. Therefore, negative 3 is a solution. Now let's check if positive 3 is also a solution. So write down the given, substitute 3 on x, and we have here the logarithm of 4 to the base 2 plus the logarithm of 2 to the base 2 equals 3. Since you have here the same basis and you have your plus sign, we can use the laws of logarithm, which is the product property, and we can also write this in exponential form. So 4 times 2 will give us 8, which is equal to 2 raised to 3. And we all know that 2 raised to 3 is equal to 8. Therefore, the left side and the right side of the given equation are equal. Therefore, 3 is also a solution. So both positive 3 and negative 3 are solutions in the logarithm of quantity x plus 1 to the base 2 plus the logarithm of x minus 1 to the base 2 equals 3. And that ends our session for today. Thank you. Stay safe. Batang manlunong, walang maiiwan, lahat kabahagi ng bilang. God bless you. Special thanks to Mr. Resi Rodelas, our EPS in Mathematics, Mr. Romeo E. Bandal, our Principal for in Aries, Mrs. Cynthia Delino, our Head Teacher in Charge in Mathematics, Ms. Jamaica Torres, our Senior High School Sign Language Interpreter, Mr. Gary T. Reyes, our Content Editor, Ms. Jelaine Enriquez, our Language Editor, and Mrs. Amelita Ibanez, our Video Editor.